All right, hello everybody. My name is Anthony and I am the game development / coding instructor here at Esports Players Club. And today we are looking at object-oriented programming inside of Python. I did a whole video series on this for the Lua language inside of Roblox Studio. And Python pretty much is not the same syntax-wise, but essentially borrows a lot of the same concepts. Actually, pretty much all of object-oriented programming is based around these fundamental concepts. And to be honest, to become a more high-end developer and just a better software engineer, object-oriented programming is a must. Most of the effective system design patterns that are used professionally in the industry are pretty much based around object-oriented programming, and you really have to understand that in order to really reach the next level of your development. So before we go ahead and actually type out some code here, let's actually talk about some of the concepts that come from object-oriented programming and what is it and why is it used so much and why is it so effective. Okay, so the idea is essentially this. In software development, and especially in game development, I argue that anything that exists in our actual world, a car, a airplane, meat, right, can be defined by two things, right? It can be defined by the behaviors that it can be formed, so put B here for behaviors, and the way it looks. These would be the properties or attributes. If I am able to replicate all the things, all the behaviors of a specific thing, and all the properties of a specific thing, I have made something that acts like that thing, right? In game development, they would generally call this an actor, but we could also create a template for this. This could also be a class as well. They're not necessarily the same, but that's the idea, right? So let's think about a car, for example. So let's go ahead and look at an example here. Let's say I wanted to make a car. Well, what does a car have? Well, a car has, the ability to drive. So in its behaviors component, we can drive it, right? We can turn it, right? We can steer, right? And obviously, I'm not going to list out all the things a car can do, but there's all of those things, right? And then the properties would be the way it looks, right? But it could also be things that enhance the behaviors, like its top speed. What's the top speed of the car, right? What's its color? How fast does it brake? How many seats, right? All of those things would be properties or attributes of the car. And as you imagine, you can have many different types of car, right? You can have a sedan, you can have a sports car, right? The idea is that you can have many different instances, but we would consider it all part of the car class, because the car class is defined by these specific behaviors and these specific properties. So this would be the idea of a class. A class is simply a template for an object, right? Where it's defined by all the things it can do, its behaviors, and all of its properties or attributes. Things like the way it looks or like the top speed of the car, right? Those will all be considered properties, right? And as I said before, we can have many different types of cars, right? So if we look at that, right, might have one car. So here's our car class, right? Might have one car where the top speed is 40, right? So this would be like car 1, and the top speed could be 40, right? So this would be car 1, and then we could have another car. This could be car 2, where like the top speed is 60, and we could have another car, and we could have many instances of the car class. So this would be the class, the template, but we have many different instances, right? This one has a top speed, I'll just put TS for top speed of, 60 or whatever. And then this one has like top speed of like 40, right? The idea is that once we create or we define what all the behaviors and properties are of a specific class or actor, right, we can then create various objects or instances of that class, and we can have as many of those as we want, right? There's many different cars on the road, right? And every Toyota Corolla is different, at least a little bit, right? Some of them are white, some of them are black, some of them are pink, right? Some of them, they change the rims on the car, right? So like all of those different things make each one of these specific instances, these specific objects, different, but they all are defined by their base properties and behaviors. And this is how you really want to think when it comes to software development. So this brings us to our first key concept that we have to understand when we're talking about object-oriented programming, and that is, what in the world does the keyword self mean? Self in object-oriented programming is going to represent the individual object inheriting or from a specific class. So whenever you're referencing self, you are talking about the specific object you are working with, right? So that's our first big concept, because most people don't understand what self is. Self is a reference to the specific instance of your class. Okay, so I just want to make sure we're very, very clear on that. And we also have to understand that all of object programming is really based around the idea that anything created in our natural world can be defined in the terms of software development by what it looks like and by the behaviors it can perform, right? In software development, we argue that if you can take something and you can replicate you really can't replicate all the things, but if you can get pretty darn close to replicating all the behaviors of something and all the properties of something, you have created something that acts like that thing, right? In game development, you would call that an actor, but in Python or a more software development, not less game development context, you would generally call it a class. But the idea is the same thing, where the class is a template of a thing, and then the objects are the individual instances of that class. Okay, so this is one of the big conceptual understandings that we kind of have to get started and understand before we really jump into actually doing some coding. Now, the next thing we want to talk about are the 4 principles that really come from object-oriented programming that are used all the time and are talked about all the time. And I'll actually show some examples here of what those are. So the first one is polymorphism. Okay, really, really big word, but I will actually go ahead and show you all something that you all should be familiar with of this right now. You see, believe it or not, you all have actually been using objects and classes this entire time. You just didn't know it. Like a set is a class, a range, for I in range is a class, right? All of those are classes, right? And so are your data types. Believe it or not, a string is also a class. It's a class of string, right? It just wasn't created in Python. You didn't create the class string, it's just inbuilt in Python. And so are ints. Ints are also classes, right? An integer is a class, right? And each one of those classes, again, are defined by what they can do and their properties, right? And the idea behind polymorphism is simply this. Depending upon the object you are working with, its behavior may change, even if the syntax you type in does not. So let's look at a very, very common example. I'm going to go ahead and type in print here. And I'm going to go ahead and print 2 plus 2. Assuming I made no typos, and it's actually in the print statement. Okay, there we go. Well, all right, so here's a very simple example of where I do 2 plus 2, right? And as you'll notice, this is the integer 2 plus the integer 2. However, if I print and I come here and I do the string 2 plus another string that contains 2, these will print 2 different results. Why? Because the plus sign here changes its behavior based upon the data it is working with. This right here is an example of polymorphism in action, and it's probably the most MORPHISM. It's probably the easiest example that I can give you to really illustrate this concept, because essentially this is polymorphism. The plus sign changed its behavior based upon the data it is working with. If it's working with integers, that is a different object than a string. Thus, the plus sign changes its behavior from addition, mathematical addition, to concatenation. And as you can see, when I run this, I get 4 here and I get 22. I get different results based upon the data I am working with, and that is polymorphism. Objects change their behavior based upon the object that you're working with. Their behaviors change based upon the object you are working with, right? So the very common example that I saw, at least in my first computer science thing that I watched on YouTube, was they talked about a cat and a dog. And the idea is that this could be a part of the animal class, right? These could be animals. So I create a class called animal, And let's just say all animals have a speak sound. So all animals have a behavior. So we'll come here and say that behavior is speak. So both of these instances of the animal class have a speak behavior, but the cat is going to say meow, and the dog is going to say woof. That is because the property of speak sound is different in a cat than a dog, because obviously dogs say woof or bark and cats say meow. So although we're performing the speak method or behavior, the result of speak changes its behavior based upon the specific instance that you are working with. And this is polymorphism. And this is one of the first big concepts of object-oriented programming that we have to be aware of, right? It's one of the foundational ones, right? But the whole idea is that specific instances and classes change their behaviors based upon which specific one you are working with, right? And this right here is the easiest example I can give of polymorphism. Okay, all right, so that's big concept number one. Let's touch now big concept number two, and that is abstraction. Okay, so here I'm gonna come and we're gonna do abstraction. And again, what I love about object-oriented programming when I teach it is that you all actually have seen this whole time. It's just one of those things that now I'm actually kind of diving a little bit under the hood of Python and talking about this stuff because, you know, it's actually been here the whole time. So the idea of abstraction is essentially a way to keep your code from people so that way they don't break the software. So let's go ahead and look at an easier example than the Python stuff, but we'll jump back to Python in a second. If I double click on the Blender application here, I don't have access to the Blender source code. I mean, I guess technically you could pull it from GitHub, it is open source, but just here, right here, the Blender application, the default one I download from the Blender website, I don't have access to the source code, right? So I can't go into the source code of Blender and change, you know, how object mode works, right? I can't do that, right? I can't go in to Overwatch the actual physical source code, right, and overwrite the start menu, right? I don't have access to that. The developers obviously would never give me access to overwrite the source code. At least I'd hope not, unless they, you know, released it to be modded, right? They would never do that, right? That is abstraction. However, I can still play Overwatch. I can still use Overwatch. I can still use Blender, but the idea is that I don't need access to all of, you know, the source code that makes Blender to use Blender. And that is abstraction. The very famous example they kind of give in computer science class is I don't need to know every ingredient inside of a cup of coffee to drink the coffee, right? I just drink the coffee. I don't need to know about all the beans and, you know, how much milk was in it and the amount of sugar and where the sugar came from and how the sugar was created. Like I don't need to know all of that. I just need the coffee in my hand and I can drink it, right? It's the exact same concept, right? And honestly, this is done to protect you, right? Because believe it or not, you know, you gave just the average Joe who has, you know, maybe very little understanding of software development, all the source code of Blender, and they go and try and change it in some way, they could destroy the application if they don't know what they're doing, of course, right? We should all know this. And honestly, abstraction is done to protect users from themselves a little bit, because if they try and go in and they change the wrong thing, well, they could destroy the entire app and maybe corrupt all their data, and then they have to re-download it, and it's a whole pain in the butt. So that's why abstraction exists. It's a way to hide specific methods and functions that you don't really need access to anyways. They're more for the developers to use when they're creating the app. You don't really need access to it, but you can still use them if you need it, right? So things like in Java, for example, getters and setters, right? Those are generally abstracted from the users. You don't need to change how the getter works, but you can certainly use a getter, right? And certainly use a setter if some of you are familiar with Java. Okay, so that's the second concept of abstraction, is essentially securing code not needed to be changed, essentially. Sorry for my messy handwriting, but I think you all get the idea. Now, let's look at an example here in Python. So what would be an example of abstraction? Well, believe it or not, like I said before, you all have been dealing with abstraction this entire time. Let's go ahead and take the very famous print, right? We all know how to do print. Print hello world. Okay? I can't change this inbuilt method inside of Python. There's nothing I can do unless I got the actual source code from the Python Institute, right? I can't change how print works. Print was built by the Python Institute. I can't change it. I have no ability to change how print works, right? I just have to use it how it comes with me, right? If I don't like the fact that they use sep to stand for separator, I can't change this keyword. I can't go into the print method and change sep to separator or end to something else, right? I just have to deal with how they made it, right? And this is a great example of abstraction. I can use print. I can use print all day long. I can print hello world. I can then print, how are you, right? I can print 7. I can use print all day long. I can drink the coffee, but I can't go in and change the amount of sugar that was put in the coffee, right? I can't come in here and change the keyword separator, right? I can't make this so it only takes 3 parameters. The print function is vardratic, meaning it can take as many parameters as I want, right? Positional parameters specifically, right? I can't come in and change the keyword argument end to ending, right? I can't change these things. These are all abstracted away from me. I have no access to it. And that is abstraction, right? I don't have access to this built-in method to change things like the keyword argument end, but I can still use it, right? So same thing, I have coffee in my hand. I can't change the milk they used, right? But I can still drink the coffee. And that's our big second principle inside of object-oriented programming is abstraction. And this is actually one of the best things about object-oriented programming is abstraction, right? So that's our second big concept. All right. Moving now on to our third big concept, and that is going to be encapsulation. Okay, encapsulation is a big one, guys. So encapsulation is actually a pretty simple concept in and of itself. And believe it or not, again, like I said before, you have been using these things this entire time, whether you realize it or not. And I'll give you a very simple example of encapsulation here in a second. But essentially, whenever you create a class or an object, all the properties and behaviors of that class should be defined within that object. It's that simple, right? Let's actually look at what that means. So let's say I created a dog class. Let's go back to dog, right? I wouldn't, and I'm defining the properties and behaviors of dog. So here's my behaviors, and then here's my properties. It does not make sense for me to define a behavior like speak, for example, but put it in another file all the way over here. That makes no sense. Why would I create a method for the dog, but put it in like the cat class? Right? That just doesn't make sense, right? Let's do something very specific for a dog. Let's say dogs can shake. Let's say dogs can shake like the trick where they shake, and the dog raises its paw and you give them a treat. Yeah. So let's pretend that this is a behavior that we're giving the dog class. I wouldn't want to give this behavior or put this behavior, which is supposed to affect the dog class, in the cat class. If this shake behavior, keep in mind this shake behavior is not affecting the cat. It's affecting the dog, right? This is a behavior for the dog, right? So I wouldn't go cat, in Python, dot shake. Sorry for my messy handwriting. And then have this affect the dog class. That doesn't make any sense. Why would I put a behavior that is for the dog in the cat class? No, you put all the behaviors for the dog in the dog class, and you put all the properties for the dog in the dog class, right? You don't spread out your methods and your functions across a whole bunch of different places. That just doesn't make any sense. It would make a lot of a really messy code base. And just like I said before, encapsulation is, should already be familiar with this. And let's look at an example of encapsulation in action. Let's say I create a list. So I'm going to come here and do my list. And we'll just do 0, 1, 2, right? Would it make sense that I had to type in, I had to make a dictionary? I did a dictionary here. And then in order to alter the list, I had to go my _dict that, you know, alter lists, I guess. This doesn't exist, but this would be if somebody didn't do encapsulation, right? It wouldn't make sense for me to have to create a dictionary to alter a list. No, all the things to alter a list should be contained within the list class, right? It doesn't make sense that I would have to go to make a dictionary to alter a list, right? And that's encapsulation. You don't want to have to do things like this. This makes no sense, right? I shouldn't have to make a dictionary to alter a list. That's bad software development, right? I should be able to just go my list, which is a instance of the list class. This specific list, my list, is a specific instance of the list class. And inside the list class, we have, I'm sure as you're aware, the method append. And then here I can append, you know, a number in, right? We should be familiar with this. You know, I can pass more stuff in here, but that is the idea. Append was a method inside of the list class. It was not a method inside of the dictionary class, which then altered the list class. That makes no sense. Why would anybody do that? That's just painful. So that is the idea of encapsulation. All the things that your object can do, and your object, the properties of your object as well, should be contained inside of that class. There's no real reason why you should have this class be different than this class, or like why shake should be in the cat class but affect the dog class. That's just silly, right? You would never want to do something like that. So don't do things like that. And that is the concept of encapsulation. Okay? And then our very last concept here is going to be inheritance inside of object-oriented programming. What is inheritance? Well, sometimes, especially in game development, this is actually huge in game development. You really have to know this for game development. Sometimes you are going to create a base class for something, right? And it has a certain behaviors and properties, right? And then you want to create a new object that builds upon that. Right, so like a good example would be a simple movable character in a game, right? Typically this is called a pawn, movable character. I'm just gonna put movable char here because I'm lazy, right? Well, a movable character could be an NPC. It could be you, the player. It could be an enemy. It could be a boss. It could be a lot of things, right? But these would all still be movable characters, right? So it doesn't make sense that if I create, you know, a whole bunch of behaviors here and properties here for a movable character, that I then have to recode them all in these classes, right? That's not what we would call dry, right? I'm repeating myself a lot. So then if I want to maintain this code base, right, and I take all these properties and behaviors and I then recode them into all these classes, right, I would have to then go back and change it in all 4 of these classes. Well, that's a pain in the butt, right? That's not very dry, right? Don't repeat yourself. So you always kind of want to avoid things like that. Sorry about that, my video cut out. But anyways, as I was saying, you always want to avoid things like that. You don't want to make, you know, the move function, right? Move is going to be pretty much the same between all 4 of these classes, right? There's not going to be any reason why I need to change the move function, right? The boss is going to, you know, I can add some parameters here. Maybe the boss moves faster, right? But the actual physical act of moving is going to be the same across these 4 classes most likely. So I don't need to code this individually in each one of these classes, because then if I ever need to alter this, right, I have to then go back in these 4 classes and change it. And what happens, and maybe it's not bad when there's 4 classes, but come on guys, we know games. It could be a whole bunch of objects that move. What if I had a whole bunch of animals? Like it's like Skyrim and I had like a wolf and a sheep and a troll and a da-da-da-da-da-da-da, right? And I have like 60 classes, right? I don't want to have to go back and change the move function in 60 classes. That's bad software development, right? Don't be that person. Please don't be that person. I've looked at too many code bases that do that. It makes me sad. Like it really does, guys. Don't be that person. Please don't be that person. Yeah, use inheritance. Just create one move function, pass 15 props if you have to, pass some parameters in here, right? But, you know, make it one move function, and then all these classes inherit this behavior. And then with this, you would probably have some properties like move speed. You know, we'll put top speed again, and then, you know, maybe min speed, right? Maybe there's an animation parameter, right? What's the move animation, right? So these would be all the properties that would get passed in the move class, and this would be all part of the movable character, right? And then all of these would have their own different parameters, but they all move essentially. The software that makes them move is the same, so I don't have to change that, right? And this is the idea of inheritance, right? Essentially, I can create a base class of something, and then I can have superclasses inherit from that base class. So that way I don't have to recode the same behavior across 60 different classes and then try and maintain all of that. It becomes an absolute mess. Now, I know we didn't do any coding necessarily today, but it's really, really important that we understand these 4 concepts because they're pretty much essential to software development, not even in game development. I'm just going to write inherit because I'm lazy, but not even just in game development in general, but just in software development. It's really important that you understand these 4 concepts because before we really do anything, you have to understand these 4 things, right? So I know we didn't do a lot of coding today, but before we finish out, there is one thing I will say about inheritance and that we have to understand, and that is you don't want to create a God class, okay? What is a God class? This is a little bit more higher end for maybe somebody who is a little bit more experienced, but if you're just watching this for the first time and this is your first foray into object-oriented programming, thanks so much for watching my video on it. What is a God class? Well, a God class is when you create a class and it holds like 97% of the functionality and behaviors, and all your superclasses only hold like 3% of its own unique functionality. Yet this is also bad. This is like overdone inheritance, right? Don't create a God class, okay? So when you create a base class, keep it simple, right? Keep it simple. Make it have like 2, 3, maybe 4 functions. Like it shouldn't need 100 functions, right? Because then essentially, if you ever have to revert this class or change this class, it's gonna break all your software, right? So keep your classes, don't make them overdone and over the top, right? And really think about that when you design software patterns, right? Don't make a God class. That is the one big pitfall of inheritance, is that people tend to make the behaviors of this be like 500 things. It can do like 500 things, and then it takes, I'm just gonna put a sad face for the amount of parameters or properties, and then this has like 2 functions. Well, what was there was no point in doing that, right? There was almost no even point even doing this to begin with, right? This should have been broken up into even smaller classes, right? This should have been broken up into smaller things and smaller things, right? So that's one thing to keep in mind. So just keep that in mind as far as your software development, right? Don't make a God class, okay? All right, so I know this was a lot of conceptual overview kind of stuff, but it's really, really important before we really jump into the code base that you really understand this stuff, because I really don't want to necessarily just jump right into object-oriented programming without a good foundational start to the 4 main principles. Those being, again, inheritance, polymorphism, encapsulation, and abstraction. Okay, so if this video helped you in any ways, please like and subscribe, and I'll see you all in the next one.